Naming alkenes. Follow this method to correctly name alkenes from a structural formula. So the first thing that you need to do is find the longest continuous carbon chain in the group. So if we look at this example here, we can go 1, 2, 3, 4, 5, 6. There are 6 atoms in the longest carbon chain. So we assign the stem hex. These are the same stems that you use for alkanes. The next step is to number your atoms so that the alkene double bond gets the lowest possible number. So that is 1, 2, 3 in this particular example. Even if you count it from the other side, 1, 2, 3, the lowest possible number would be 3 for this example. So this would be called 3-hexene. The next thing you need to do is identify if there is any geometric isomerism. So that basically means if there's a cis or trans isomer. In this case, we have the carbon substituents coming from the double bond on opposite sides of the double bond, and therefore this is identified as the trans isomer. We could therefore name this trans 3-hexene if this substituent group here was in this position, it would be cis 3-hexene. Let's look at some other examples. So the first one is very easy. We just count the number of carbons. So there is only 2. So it gets the stem of F for 2. And it's a double bond there, so it's ethene. We don't have any structural isomerism, so we just call this ethene. You could call it 1-ethene, but when there's only 2 carbons, the position of the double bond is implied, so you don't need to do that. Let's look at another example. In this example, we have 1, 2, 3, 4, 5 carbons in the longest chain. So that would be pent. So this is pentene, and we need to name the position of the alkene bond. So that's first position, so it's on carbon 1, the alkene, so it's 1-pentene. And then we need to describe if there's any methyl groups and any cis-trans isomerism. So there's no isomers here because on one of the carbons there's no substituents. So we can't have a cis-trans isomer here. However, in this example, we do have a methyl group and we need to describe where that is. So the methyl group is on carbon 2, 1, 2. So this is 2-methyl 1-pentene. I'm going to write that down. Let's write the name of this one as well. Now let's look at another example. This example here has 1, 2, 3, 4 carbons. So it is going to be 4 is meth, eth, prop, and I'm forgetting these today. Bute. So this is butene. And we can see that there is no cis-trans isomerism because this carbon does not have a carbon substituent or a fluoride substituent or anything like that hanging off it. It's got the same functional groups on either side, so hydrogens. So this is simply methane. Yep. So we write that down. However, we need to give the position of the carbon bond, so it's 1-methane because the carbon double bond is in the first position. Okay, let's look at this last one. It's a little bit trickier. This one has 1, 2, 3, 4, 5 carbons inside the structure, and it has, so it's pent, says pentene, so we can write that down. However, this one has a double bond at position 1 and position 2, 3 as well. So it's actually 1, 3, and because there are 2 double bonds, we say it is dipentene. 1, 3 dipentene. There are no functional groups hanging off the side, so that's the final name for this. Let's look at some more complicated ones with cis-trans isomers. So the first one, we have 1, 2, 3, 4, 5. So once again, it's pentene. And we have the double bond at position 2, 1, 2. So it's 2 pentene, and now we need to describe if there's any functional groups. There's not, and if there's any, or branches that is, and if there's any cis-trans isomerism. So we can see that there are these 2 substituents hanging off the double bond, and they are on the same side of the molecule. If they're on the same side of the double bond, then they are cis. So it is cis 2 pentene. Let's have a look at this more complicated one down here. So this one we have 1, 2, 3, 4, 5, 6, 7, 8. So 8, that's octene. We need to describe the position of the double bond, so that is 1, 2, 3, 4. 1, 2, 3, 4, the same from either side. So it's 4 octene. We also need to describe if there's any methyl groups or ethyl groups or other substituents or branches, and there's one here at position 4 and there's one here at position 5. So that would be 4, 5 dimethyl 4 octene. The last thing we need to do is to describe if there's a cis-trans isomer. So if we look at these carbon substituents hanging off the double bond, they are on opposite sides of the double bond, and therefore it is the trans isomer. Trans 4,5-dimethyl 4-octene. Last one, this one's quite complicated, and it is looking for the longest carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's actually decene, or dec for 10. So we can start writing this now. The position of the double bond is at position 1, 2, 3, 4. Now we need to describe whether it has any branches or substituents hanging off it. We have a substituent at position 1, that's a methyl group. We have another methyl group at position 2. And that is all the methyl groups. But we also have this large propyl group at position 1, 2, 3, 4, 5, 6. So that would be 6 propyl, 1, 2, 4, 1, 2 methyl, 4 decane, and now we have the final step, which is identifying if there's a cis-trans isomer going on. And if we look at the double bond, this large group here and this large group here are on opposite sides of the double bond, so it's trans. So it is trans trans 6 propyl 1, 2 dimethyl 4 decene. So there are lots of other examples in the worksheets that I've given you. So if you're not understanding these, then have a go.